Oh, g'day champions. Here's one that I ripped apart on the live stream last weekend before. I don't know, all the days are blurring together. Bit of a weird one. It ended up having like 8 different faults, which is often the case. They were stuff that wasn't cascaded failures either. I think what happens is you'll have a whole bunch of issues, and when the final nail gets put in the coffin and it stops producing signal altogether, or the lights just don't turn on, that's when the customers bring it in. But it might have had niggly faults before that, which for whatever reason they may not remember or disclose. So I'll show you the footage from the live stream of when I was first checking this thing out, and we'll mix that together with my findings after the fact. Alright, so what have we found? We found a broken PCB trace. So this is quite common. Not only do thermistors have a bit of mass to them, but they also get hot during normal operation. The way they work is they've got a high resistance when they're cold, and when they're hot, they've got a low resistance, so negative temperature coefficient. Their job is to reduce the initial inrush of energizing this honking big transformer and charging up those big reservoir caps, which are what, 4700 microfarad, 100 volt 2 of. So they'll act like a resistor at, well, when they're cold, then they heat up and they sort of become like a wire and don't limit the current through this thing much, significantly anyway. But they've got quite a bit of mass to them, and no one seems to ever mount them properly. So you get what we have here. See the arcing that's occurred? This has got mains across it. It's not enjoying life. So that pad's basically removed itself from the PCB. So I'll just remove that entirely. And that pad, is that pad gone? No, that's just a solder. So that's interesting. It's like the solder never took to that, because you can still see the gold. So we might be able to resolder this and just secure it properly, like silicon it to the board or something. Because look at that. Look at the soldering effort. All around here is untouched gold. Once you've touched solder to that, you never see that gold again. It's always going to be... Yeah, look, the solder's just come off, and it's all gold underneath. So the solder's never taken to that. So we haven't damaged this PCB, it was just never soldered properly from the factory. Wow, quality. Jeez, I get the good jobs, eh? Yeah, it looks like the arc might have vaporized a bit of pad there. I don't think solder will take to that, but fortunately we've got one right next to it. So what I'm going to do here isn't very pretty, but it will work. We'll just stick a bit of silicon in that gap there, just to damp vibrations. We don't need to secure it, we just want like a little shock absorber there. So, because this is a bass amplifier, we want a shock absorber that'll just stop the thing, just damp vibrations, you know. Click. We've got no light on the VU, no signal. Nothing's that easy, legends. Okay, we've got blown 15 volts. Didn't see that before. I forgot that it's got fuses on the bipolar. Alright, why is that occurring then? Both the 15 volt rails are shorted. So that's where this fucker comes into play. 0.07 ohm. So we'll null that out. Null. Now we're at 0.00. From the point right at the regulator, we've got 0.176 ohm. So I'll just put that on the ground bus, and we'll try to find the lowest resistance throughout the board on that. So literally that cap, the cap is the lowest point, so 0.16, 0.2, so it must be that cap. That's how you find a short. 0.1617 ohm. Shorter cap, looks fine visually. JKEK, 16 volt cap on a 15 volt rail, you nuffies. Right, I know that we've removed that short, but we'll double check with the Fluke. Alright, is everyone ready for the third issue? 2 issues and counting. Alright, third issue, no output. No output from the power amp either. So, third issue, that fuse is open. That wouldn't be why we're not getting signal, because that's got nothing to do with the amp itself. So we've got 4 issues in this amp, independent of each other. Alright, let's see where this signal's making it up to. Can't have a repair these days without having to turn the scope on, champions. At the input, it's 1 volt peak to peak. So there's literally no gain from front to finish. Alright, so we've got another problem on the preamp board. Let's pull that. have a look with it unloaded. There could be a shorted front end somewhere. No, still got small signal. So we've got a fan problem. We've got another problem on the preamp. And we've got another problem in the power amp. Because the fan wouldn't stop signal at any capacity. It's nothing to do with it. That tiny signal that's coming out is too low from the preamp board. But you'd still be able to hear it from the power amp. Half a volt peak to peak you'd still be audible from the power amp. So there's still a problem with the power amp, and there's a new problem with the preamp. And if you like those snippets of the live streams, tune in with us 7 AM Sydney time most Saturdays, unless I've got other stuff going on. You can watch me ranting and raving in real time and doing funny things like electrocuting myself live on stream. Or should I say shocking myself, because I'm currently still alive. Alright, so one more issue, of course. The Speak-On / TRS combo jack is playing up. See what the other one's like. There's two on output parallel. Alright, so that one's good, but that one's intermittent. Now I could leave that on and just give them a note, but what happens is they forget, they plug into the wrong input, then you end up with an angry customer coming back saying after they spent the money it's intermittent still. So for the sake of like a $12 jack or whatever it is, I may as well just take it out and replace it. But to do that, we've got to remove the transformer, because that board's got to move backwards and come under this lip here. So we'll have to unbolt that as far as the leads will allow, sort of pull it back this way and then pull the board out. There's always something, champions. If this job was easy, I'd have like 3 boats and 2 houses by now. But yeah, got my beautiful little rat shit here. Nothing like a good rat shit. Okay, I thought this had the square-headed hex bolt, but it doesn't, so we'll have to get a spanner or something on that as well to hold it. Whatever paint or Loctite or whatever it was that they used on the top means it's hard all the way. But we're there. Pull the bolt out entirely. Alright, managed to sit it upright, take the weight off the transformer so it's not pulling on the leads. We'll change that left-hand jack out. Now these are Neutrik combos. So a little bit more expensive than your average jack, 1/4 inch jack or Speak-On. So the green colour of them designates that you can take a 1/4 inch plug in the centre, but it's also compatible with your standard Speak-On plugs as well, in this case 2-pole. Now one thing I might add, I don't know if they need more Weet-Bix shipped to the factory, but on every Ashdown amp I've had, every jacket and pot has been like barely finger tight. There's no lock washers on them, so it could be a vibration thing, particularly in the combos, but this is a head. And I've never had them come undone or come loose but not undone. So I don't know, it just seems like they should nip them up a little bit tighter, but that's a bit weird. The one that's good, firmly seated against the board, and the one that's not, she's wibble wobbling around. I think we might have another fractured lead here, because those solder connections look okay unless it's pulled out from within the dome. But like everything on this amp, and pretty much everything these days is lead free, so I like to put a little bit of leaded solder on there just to get the flux out of it, but also it slightly lowers the melting point too, so it makes it a bit easier to remove. So looking at the terminals on the back, they seem to be in okay shape still. So I think what happened was we had an internally broken solder connection, but the dome on the bottom was still intact. That's another reason why you shouldn't have a massive dome of solder, because if you've got a little fillet, you can easily inspect to find the bad solder joints. If you've got a big glob, a big ball of solder on there, then you can't visually tell if a solder joint's gone funky without, you know, having to just rely on the symptoms. So we'll reuse that one, but I'll just make sure it's bedded properly against the PCB. Alright, so that's about the solder you want on there, a sort of concave fillet towards the end of the terminal. Having a big blob of solder on there doesn't give it any more strength. It's still going to fail. What's important is having the component seated all the way down on the board, so it's not relying on the solder connections solely to keep it in place. I'll clean that flux off and we'll get this board back in and just double check that connector's okay now. Then we've got the opposite problem on the Speak-On screws, which are just like self-tapping plastic screws, wood screws. They've over tightened them, so you can see all the plastic's stripped out and it's only hanging on by the last 2 or 3 millimeters. So there's no happy medium. It's either too tight or too loose. And one important thing I've seen some manufacturers do these days is they forgo the cost of, or maybe another repair tech actually I should note, has forgotten to put that plate and its rubber washer back in. If you use the plate by itself, you can rub through the insulation and have a short to ground. And if you don't use the plate at all, what happens is this epoxy plug here pulls through, and eventually it either damages the windings in the inner side here, because it is slightly flared out by the time that the epoxy is finished, or it can just pull it through and the whole thing can come loose and rock around inside the box. So always make sure you got the plate. Every toroidal transformer I've purchased comes with one anyway, so there's no excuse not to use it. I think some techs just misplace them and they just, whatever. And they tighten that bolt down, and then the epoxy plug starts moving and they go, I didn't see nothing, boss. Alright, one thing I'm not a big fan of on this and other amps, Orange are guilty of this as well. I think some Vox amps as well. They use the spline shafted pots, and they use like these universal knobs which aren't really machined or molded to suit exactly those splines. You can see down here that same mold would be used to make the set screw version as well, because that's normally where its washer sits, down inside there with its threaded section and the grub screw through the rear end. But these being universal, they've got little ribs in there, but they don't necessarily line up with the splines, so they put undue force on the thing and sort of compress it. And the first time you install the knobs on the pot shafts, they sort of bend together like that. Now it's only sort of tight right at the very end, and they sort of can wobble around a bit. And if you try and bend that back out, this pot metal just breaks off, and then you've got to replace the pot. Now these are weird PCB mounted pots with extra long posts that are somewhat difficult to find. So you want to do what you can to avoid having to replace them, because you'd have to sort of hardwire something and then run wires and make the reassembly a bit awkward and whatever. So just be careful. Just be gentle with the shaft. Be gentle with the shaft. Sometimes it's nice to be a bit rough, but not all the time. Alright, champions. Bit of an epic journey for what basically was, to the customer, one symptom. It's always, it's really hard to explain to a customer that there can be multiple things wrong with only one symptom. They're used to like their car where it makes a funny noise. Well, that's your fan belt. You know, that's your steering pump. Just like one thing. Often in amplifiers and other devices, there are multiple issues causing one symptom. You can have cascade failures where one fault has caused 2 or 3 or 4 or 5 other things to fail, which is very common in solid state stuff where everything's direct coupled. Or you can just have weird ones like this where there's a whole bunch of unrelated stuff which all needs to be sorted, which it now is. You can have preventative maintenance where there's things in your experience or visually they may be on the way out, or it's just time to change them, things like caps, to avoid future issues, and so you can stand behind the restoration or repair work and be confident that it's going to be reliable for the customer in the long term. So in summary, let's go through what we found in order, roughly I think, of what I found it in. So the first thing I found, and what I thought would be a home run, silly me, was the thermistor. Next was these 2 fuses. So this is the low voltage windings here, and that's your 2 AC fuses. This is a good way of doing it. I do like this, because then even if one of your diode goes short, because the fuses are on both sides of the AC winding, they're guaranteed to blow. So this is a really good way of fusing secondaries. If you're going to fuse it, you go the whole hog, fuse every winding, so that will give maximum protection. But one or both, I can't remember, of these had gone open circuit. First thing I tested was the diodes. They were all fine. Next thing I tested was the regulators. I noticed there was no output on, I think it was this one, and that was because one of these caps had gone short circuit. So I replaced both of them with Ninja Cons. I'll put a little bit of dab of silicon in there before we button her up, as well as on the other ones that are still remaining from the factory. So this is the replacement. It got super hot the previous one, so that could have caused some damage as well. I just thought, well, I got the board out, I'll just replace the regulator as well, because it's what, $2, and well, we've got the board out, but Little did we know champions would have to take it out again, but you know, wishful thinking being what it is. So after all that, we still had no signal. So then I tracked it down to TR7 being short circuits. So that was shunting all the audio to the voltage control bus for these FETs, for the channel switching, or not channel, but the feature switching. They're basically working like analog switches. So we replaced that. That sorted all the issues out on the front board. Then the next issue was no fan operation. So I tracked that down to this fuse being open circuit, and that being because the cap they put hugging this heatsink over here was not up to the job, and it had gone short circuit as well, blowing the fuse, and the top was a little bit bulgy as well. Wasn't super evident. Normally the top bulges up like crazy, but this one actually had a bulged bottom as well, like big butts, and I cannot lie, but not on my caps. You can see there was a little bulge to the top, just enough to notice the reflecting light, but the bottom was really bulgy, and that was probably about to pop. And she'd gone short and blown that fuse. So I upgraded that. 16 volts was fine. I put another, I only had a 25 volt Nichicon in there, but the lead spacing and the footprint was suitable, so I put that in there, and that's a 105 degree rated 10,000 hour cap, so that should last a long time. Now the other cap that loves to fail on these, is sort of cynical side of me, says planned obsolescence. Is that little one down in there? So she's hiding between the two hot heat sinks there, and not only that, but there it's like 160 volts potential away from each other. So you know, if you rub through that insulation of that can, it could, well, if you jammed a too big one in there anyway, you could short rail to rail, or just rail to the can of that, which would probably have some funky behaviour as well. So fans work. Happy days. It looks like they're spinning really slowly there, but that's just the shutter speed. Don't stress about that. Now, just in case you didn't believe me, don't touch these heat sinks while the thing's on, or even after it's been turned off. Test them first, because we've got 162 volts across them. In my opinion, energized heat sinks is a bit shit. Spend the extra money on a couple of washers and insulate the thing. Because if you're sliding this out of the box just after it's been turned on, that's probably the first thing your hand's going to touch as you pull it out from the lip here. So yeah, it's a couple of bucks worth of micro washers or silicone rubber washers these days, you know. Now the other hazard to be aware of in these things, I wouldn't advise anyone takes these apart to service unless they're experienced, but even to experienced techs, this is usually a bit of a rarity. You've got your preamp valve there with its own independent power supply, sitting at 362 volts DC. Now when you switch off the amp, that valve continues to conduct for a while, but it only drags it down so far before it cools down so much that it stops conducting and stops dragging that voltage down. Alright, so that's been sitting there for about 10 minutes now. It's sitting around 126 volts. The meter's dragging it down a bit. If I take the probe away for a while and retouch it, it sort of stays about where it was. So that's what I displayed, demonstrated to comedic effect, I'm sure you'll agree, during the live stream, which was quite embarrassing. But, you know, we're all human, and some of us are dumber than others, and I'm probably towards the mid to low spectrum there, so it is what it is. Live and learn. But what we could do in that situation is put like a 470k resistor from maybe terminal to terminal on one of those caps, probably the latter one, and that would slowly drain it off. So if it has been sitting for a while, it would actually eventually reach zero or very close to it. In my opinion, if I was designing this amp, I would have put that in as a safety measure. I think there may even be some compliance rules that's required. I'm not sure. I know there is on the primary side. In the case of switch mode power supplies, that kind of thing, but not sure in secondaries and auxiliary power supplies like this. Probably a bit of a grey area, which is why they get away with it. Alright, just looking at the scope, and that speak-on connector is now good with a 1/4-inch jack input, so that's good. Sitting in idle, we're only drawing about 20 watts, which is a bugger all. Just checking the emitter resistors without touching the bloody heatsink that's energized. Got almost no idle current, so that's why the idle power is so low on these units, because they're bias very cold. Alrighty, so we're going in 4 ohms. We're starting to hit the wall at about 42 volts AEC RMS, so that equates to about 440, 450 watts RMS in the 4 ohms continuous. Which brings me to the next point, somewhat less pleasant one. So, power ratings. Output power, 500 watts RMS. Close to it, but not quite. 1000 watts peak. Okay, I'll take your word for it. The issue with this is on their speakers, they don't say peak or RMS or anything. They just say 1200 watts. It's up to you to guess. Doesn't say anywhere in the documentation, in the manuals or anything. Just know that their speakers are, they're quoting peak, whatever that means, and to pretty much halve it. So say it's a 1200 watt fridge with 8 speakers in it, like they currently still offer. Don't feed that with more than, say, a 500-600 watt RMS output amp, because you'll probably blow the thing up, as some of my customers have recently found out. Anyway, they're, aside from all this stuff, pretty reasonable amps. I don't mind them. I think they sound good. The preamp's well designed. And another thing just to be aware of, champions, is on a lot of Ashdown schematics, they've got the component designators there. Yeah, that's cool, but no component values. So if you've got like a burnt component or something where you can't read the original value, makes replacement a bit of a pain in the ass. Alright, one common problem on these is the filter caps rocking around and breaking their solder connections to the board as well. In this case, it looks like they've had to deal with it for a while, and they've figured the best solution is to just cable tie them both together and put a little bit of glue at the bottom, which in this case has worked. Down there's your monster bridge rectifier that could have been about a quarter of that size if they had it bolted to a chassis, but does the job. I've never seen that part fail in these amps. Sometimes the lamps in the meter go, but you can access that for replacement. It may be increasingly hard to find replacements for that aren't LED based. So next thing I'm going to do is stress test this a bit, test that the fans are ramping up and down as they should be. We're going to run it at around 1/3 the voltage output, which is about where a Class AB amplifier, discrete amplifier, is most stressed, most inefficient, and generates the most heat percentage given the power consumption. So you've got a thermistor down there hiding behind that cap. That's actually controlling the fan speed. So it's what we call a negative temp coefficient. The hotter it gets, the lower the resistance, faster the fan spins, the more ripums, and the more air it blows through at those heat sinks. It's pretty much the same as the one on the mains we talked about earlier, but just different spec, different voltages, different temperature, resistances, blah blah blah. The fans are indeed ramping up somewhat, not going off the head, but barely audible when the amplifier's idling, but now they're starting to rev up a bit, so that's all functioning fine. I'll just leave it there for a bit and just make sure nothing happens, and make sure that thermal cutout switch there doesn't trigger or anything like that. You can see the fan supply circuit there. It's got FS1, which was the blown one because C22 had gone short circuit. A thermal switch there, which isn't present on this model, but that would cut the fan off completely below 70 degrees, so it's quiet. And then you got your thermistor there just before the fan in series with it. Very basic, but it does the job. And your fan itself, there's 2 fans, they're just connected in parallel, where it's showing one fan connector. That's just the screw connector, and it's got 2 fans plugged into the same terminals. And one other important thing to check with these amps before you box them back up again is the TR10 down there. That's the bias spreader transistor. It should be thermally coupled. Make sure that paste hasn't dried out or it has come away from the heatsink. It's got to be thermally coupled, so it forms like a negative, almost like a negative feedback circuit with the transistors there. As the heatsink heats up, they could run away and overconduct, and that pulls it back a bit by changing the bias voltage supplied to their bases. Alright, so we're putting out a continuous 250 watts into the 4 ohm load, and we're pulling about 575 watts from the wall. If we give that a quick burst up to, hitting the rails, we're pulling about 820 watts there, so... But of course, sending the output stage into hard clipping is not exactly a use case scenario that a sane person would put the amp through, but, I've seen stranger things happen. So there you go, champions. Another one bites the dust. We'll get this back in the box. I've taken all the measurements, and I quote that on all the invoices, the output power, the voltage rails, the ripple, the idle current, all that kind of stuff. And we'll get it back to the customer and move on to the next one. So I'll see you on that one, champions. Like and subscribe, or I'll tell everyone you're a Nickelback fan.